Can you start? It's 3:10 almost. Okay, so what was our last topic? We talked about some traversal methods of graph, isn't it?
Yes, ma'am.
Yes, ma'am.
Okay, so did you find any problem in those traversal methods in DFS and DFS? Do you have any confusion in DFS and DFS?
No, ma'am.
No. Okay, so today we'll actually discuss about some sorting algorithms. Okay, so far we talked about how many sorting algorithms. The first one was bubble sort, and then insertion sort, selection sort. Three we discussed about heap sort. Right. So we talked about these four types of sorting algorithm. And we all know what is sorting. Sorting means just rearranging. A data set is given, we just have to rearrange it either on ascending order or in descending order. That is sorting. And we know how to sort the data or array using bubble sort, insertion sort, selection sort, and heap sort algorithm. Right. And among those four sorting methods, we know that heap sort is slightly different than these three. Why? Because heap sort at first we need to draw a heap tree, then we can apply this heap sort algorithm. In bubble sort, insertion sort, and selection sort, we can directly apply those three sorting algorithms, right? So can you tell me which algorithm among those four is faster? Which one will take less time for sorting the array? For bubble sort, insertion sort, and selection sort, the time complexity of average case was big O n square, order of n square, right? For insertion sort also it was order of n square, and for selection sort the time complexity was order of n square, and for heap sort the time complexity was order of n log n, right? So which one is faster? Which one is a faster sorting algorithm?
Heap sort.
Very good, heap sort. Okay, but now when only the array is given, suppose it's nothing to do with the tree, some data elements are given, we can store them in an array. Now we have to apply some sorting algorithms for arranging them. So at that time, if we apply bubble sort, insertion sort, and selection sort algorithm, it will take same amount of time, order of n square. So can we use another algorithm which is a lot faster than this tree algorithm? Yes, there are two algorithms. One is merge sort and another is quick sort algorithm. Okay, so these two sorting algorithms are faster than bubble sort, insertion sort, or selection sort algorithm. Okay, so we'll discuss about these two sorting algorithm in today's class. For merge sort, the time complexity is just like the heap sort algorithm, order of n log n. In best case, worst case, or average case, the time complexity is order of n log n. For quick sort, in average case, the time complexity is order of n log n, but in worst case, it's order of n square. So at first, we'll talk about this merge sort algorithm. Okay, so now suppose an array is given. The array is 4, or some data elements are given 4, 12, 6, 9, 7, 5 to 11. Okay, so now so look at the arrangement of the data. The first one is 4 and then 12, 6, 9, 7, 5 to 11. Is this a sorted list, sorted array? No. Okay, so now we can store the data elements in an array, and what will be their index? If we start from 0, the index of 4 will be 0, then 1, 2, 3, 4, 5, 6, and the last one is 7. How many data elements are here total? N elements. So an array with 8 data elements are given. And if we want to sort them, or after sorting it in ascending order, the array will be like this. At first we can store 1, then 2, 4, 5, 6, 7, 9, and 12. This is our sorted array, right? So in merge sort algorithm, now we will apply a different method. What is the method of merge sort algorithm? There are two techniques we have to apply. One is divide and another is conquer. Here we can apply the divide and conquer method. So what does that mean? When an array is given, look at this. What is the problem? The problem is sort the array either in ascending order or in descending order. Right. So at first we have to divide this problem into some sub problems. How we can do that? If we divide the array into some sub arrays, then we can create some sub problems. Okay, so now here the first index value is 0. That means lower bound is 0 and upper bound is 7. So which one is the midpoint? Lower bound is 0 and the upper bound is 7. Or how many elements if we divide this n by 2? N by 2 equals to 4. N by 2 equals to 4. So how we can divide this array into two sub-array? We're going to take the element from 0 to mid minus 1 into one sub-array. So here the first index is 0, that is our lower bound. We will take the elements from lower bound to mid minus 1, that is from 0 to 3. So the first 4 elements will be stored in the first sub-array 0, 1, 2, 3, and here the data are 4, 12, 6, 9. And rest of the elements, that is from mid to upper bound. So here mid is 4. All the elements from 4 to 7 will be stored in the second sub-array. So how we divide the array? The given array is divided into two halves with equal elements. Okay, so here we took an array with even number of elements. That's why we can divide the array into two sub arrays with equal elements. So here the data are 7, 5, 2, 11. That was an array, and now the given array is divided into two sub arrays. So we are applying divide method here. Divide, that means divide the array into some sub array until each sub array has only one element. So look at this sub array. How many elements the first and second sub array has? 4 elements. We have to continue this process until we get some sub arrays with exactly one element. So now this sub array will be again divided into two sub array. Okay, so now each sub array will have how many data elements? 2. Okay, so the first two data 4 and 12 will be stored in this first sub array. Okay, and then the 6 and 9 will be stored here, 6 and 9, and the index value will not be changed to 3. And then again, this is our array A. This is the left sub array, so we can call it L, and this is our right sub array R. Okay, so now the right sub array will be divided into two sub array, each with 2 elements, 7, 5. Their indexes are 4 and 5, and then 2, 11. The indexes are 6 and 7. Okay, so now look at this. At first we had only one array with 8 elements. After dividing the array into two sub arrays, now the left sub array has 4 elements and the right sub array has 4 elements, right? After that, again we have to divide the left and right sub arrays into some equal half sub arrays. Okay, so how many sub arrays we have now? 4 sub arrays, but here one sub array has how many elements? More than one elements. Again, division. So divide this sub array. So after dividing it, now this sub array will be divided into two sub arrays, one with exactly how many elements? One element. First sub array is 0, 4, and then 12, 6, 9. Now this right sub array will be divided 7, 5, and 2 and 11. Okay. So now this is the end of the division process. Why? Because now we have exactly some sub arrays with how many elements? Only one element. And we know that when an array has one element, that array is sorted because there is nothing to compare. There is only one data. So now look at the last step of this division process. We got how many sub-arrays? Exactly n number of sub-arrays with one element, each with one element. This is our division process. What is the name of this sorting algorithm? Merge sort algorithm. And what is merging? Merging means combining some arrays together, So here we have to combine all these sub arrays into one sub arrays where all the elements will be in sorted order. At first we have an array with some elements and the array was not sorted, and then we divided the array into some sub-arrays, and after getting one element in each sub-array, now you can stop this division process here. The next step is merging, combining these data elements together, because the the output will be one array which is in sorted order. Okay, so now how we can combine or merge these sub-arrays? Can we just exactly take the same data, I mean 4, can we place it in location 0 and then 12 in 1? No. So what is the next step? Now we have to compare the data elements of two subarrays. The first subarray is 4 and another is 12. Now compare these two data elements. Here 4 is less than 12, isn't it? Suppose here this is our left subarray and this is our right subarray, and we can use a variable I and another variable j here, and this is our original array, and here we can use a variable k. So now look at this, how we are going to compare the data elements from the left subarray and the right subarray. Okay, so at first we have to reach to this point. Okay, so this is our final step of division process, and how we can compare two elements? We can compare to neighboring elements. Compare 4 and 12. 4 is less than 12, so we can store 4 in location 0. Its index will be 0, and 12 here. Now the next two element is 6 and 9. Look at this. This is our left subarray. This is the left subarray. Okay. So compare these two elements, 6 and 9. 6 is less than 9, so 6 will be stored first and then 9. If you want, you can at first work with the left subarray and then you can compare the elements of the right subarray. Okay, so here in the right subarray, the first element is 7 and the next one is 5. So if we compare these two elements now, 5 will take the place of 7. 5 will be stored before 7, right? So here, look at this. The swapping will be done in this way. Here, suppose AI is less than, or here actually AI greater than AJ. Or since we are using, this is only, these are some subarrays, so we can simply say that AI is greater than AI plus 1. And here suppose I goes to 4. So A4 is greater than A5. So how we can change this to value? We can use a temporary variable, and this data element will be stored in temporary variable. How we can perform this swapping? 7 is greater than 5, right? So 5 will take the place of 7. So at first we can take the data element from I and you can store it in temp. Temp equals to AI. Then what is the next step? Now AI plus 1 will be stored where? In AI's location. So we can write AI equals to AI plus 1. And what is the next step? From the temporary variable, we can take the data and we can store it where? In AI plus 1. So the last step is AI plus 1 equals to AI. So here 5 will be stored in location 4 and then 7. Now the next data is 2 and 11. 2 is less than 11, so swappings are not needed. We can store 2 before 11. Okay. So after merging these sub-arrays, now look at this. How many sub-arrays we have? 4 sub-arrays, isn't it? So what should be the next step? The first process was division. Divide the array into some sub-arrays until each sub-array has how many elements? 1 element. What is the next step? Now merge the sub-array, because we have to create only one sub-array. Sorry, only one array, right? So how we are combining the arrays, how we are merging the sub arrays after making some comparisons, right? So now this is our left sub array and this is the right sub array. So what should be the next step? Hello. What should be the next step? We're using some recursions here. That means you're repeating the same process, right? So now we can merge these two subarrays together. Okay, so in this subarray is already sorted and this subarray is sorted. That means the first element is obviously smaller than the second element, right? So now here we can compare the first element from this subarray with the first element of the second subarray. Okay, so here the first element is 4 and this is 6. So 4 is less than 6, isn't it?
Yes, ma'am.
We are going to merge these two sub-arrays. So there will be, after merging, it will get one sub-array with 4 elements. Their indexes are 0, 1, 2, 3. So here, compare now 4 with 6. This is our left sub-array, this is the right sub-array. Okay, so here 4 is less than 6, so swappings are not needed. 4 will be stored here, isn't it? So what should be the next step? After comparing 4 with the first element of this sub-array, we can see that this element is less than this element, 6. Then we placed only 4 in its correct position, that is 0. What is the next step? Now, increase the value of this loop variable. Now we can compare 12 with 6. Okay, here suppose for left subarray we use a variable I, for right subarray we can use j, but here both are the part of the left subarray. Okay, so here the first element of this subarray is less than the first element of the second subarray, so we don't need to change their position. The first element is 4, so here its loop variable will be increased by 1. Now check whether this element is less than the first element of the second subarray. So here 12 is greater than 6, right? So here 6 will be placed here, and then can we place 12 in index 2?
No, ma'am. You have to compare.
Is this the correct position? No, we didn't compare it with the second element of the third subarray. So now compare it with 9. 12 is greater than 9, so here 9 will be placed and then 12. Now look at the right subarray. The first element is 5, compare it with 2. 5 is greater than 2, so now 2 will take the position of 5. At first 2 will be 0. Okay. So what is the next step? Now this index value will be increased. Now compare 11 with 5. Compare 11 with 5. 2 is already placed in the correct order. So 5 is less than 11. Hello, can you hear me?
Yes, ma'am. Got it.
How the swappings are done? This is index 4 and this is 6. So we are comparing two elements from these two index 4 and 6. Okay, so after swapping now 5 is actually here. 2 has shifted to this position. This is 2, and temporarily we can store 5 here, but this is not the appropriate place for 5. So what is the next step?
Compare
Which index will be increased? This one or this one? For which subarray the loop variable will be increased? Obviously this one, isn't it?
Yes.
So now which data element will be compared, 5 or 11? Obviously 5. So now compare 5 with 7. Now 5 is less than 7, so again swapping. So 5 will be stored in where? Location 5. So here 5 can be stored, and then now 5 is here and 7 is stored in position 6. So now we can compare these two elements. 7 is less than 11. Okay, so now the third data will be 7 and then 11. Now these sub-array is sorted. Look at the first sub-array, 4, 6, 9, 12. This is sorted in ascending order, and this sub-array is already sorted, 2, 5, 7, 11. But now we have to continue this merging process because the final result will be a single array. A single array. Okay, so there are two sub-arrays. Now again merging. This is our left sub-array and this is the right sub-array, and here we are using the loop variable I, and here the loop variable is j. The initial value of I is 0 and j equals to 0 because we will start comparing the data from the first index. Okay, so now li, compare li with rj. Suppose the name of this left sub-array is L and the name of the right sub-array is R. So Li, when I equals to 0, that is L 0th element is 4, and in Rj when j equals to 0, that is Rj equals to 2. Now compare Li with Rj. Here Li greater than Rj, isn't it? Li greater than, and this is our final array. I'm not writing the array here. This is our array. Okay. So 4 is greater than 2. Now 2 will take the position of 4. 2 will be stored here. So this is 2. This is our final array. This is 2. Okay, so after this swapping process now 2 is here and we got 4 here. So what is the next step? Now the value of I will be increased or j will be increased. Which one?
I will be increased.
I will be increased.
I will be increased. So what is the new value of I? 1.
1.
Now compare 6 with the first element of R, that is 4. Compare 6 with 4. Now again 6 is greater than 4, right? So again swapping. So 4 will be stored here. Okay, so in the final array we can store 4, or if we are using a loop variable k here, then we can say that if li is less than rj, then k is 0 equals to, what will be the, ak equals to li. Look at this, the condition is if li greater than r less than rj. Suppose li equals to 2 and rj equals to 4. So the condition is true. Then we can write a k equals to li. Yes. Suppose we got this one, this value 4 when I equals to 0. So now in that location, initially all the loop variables are 0. Their initial values are 0, equals to 0, j equals to 0, and k equals to 0. Suppose this is our first comparison. When I equals to 0, we found that li is less than rj. Then how we can change the value in the original array? Now li will take the, where we can store it in ak, right? So this is k equals to 0, so li equals to 2 will be stored in kth position. When k equals to 0, we can place it in memory location 2. Is that clear? And after that the value of k will be increased as well as the value of I will be increased. This is one condition. Another condition is when li is greater than rj. The second, can I remove this portion? Okay. What is the second condition? Another case is li is greater than rj. Okay, then how we can change the value? Then you can write a k equals to rj, isn't it? When li less than rj, suppose I equals to 0 and here li equals to 4 and rj equals to 2. So 2 is less than 4. So which value will be stored in k equals to 0 in that location? Obviously rj. So you can write ak equals to rj. Okay, then the value of k will be increased as well as j will be increased, j plus plus. Okay. So now here when I equals to 1, li is greater than rj. So which condition is true? Obviously this condition is true. Then how we can change the value? Now k equals to 1. So in this position we'll store rj and rj equals to 4. Is that clear?
Yes, ma'am.
Yes, ma'am.
Okay, so this is 5 and this is 6. Okay, so now which value will be increased? I or J? I or J?
ma'am.
J.
J. Okay, so if we increase the value of J, then from where we should start? What is the value of J now?
5.
Suppose I is here. What is the value of I now? I equals to 1. I equals to 1. Okay, so now what is the value of J? J equals to 0. J equals, we already, this is our sorted array. Okay, so now compare 5 with 6. Now which condition is true? This one or that one? The first condition here, Li is less than Rj. What is the value of k now? K equals to 2, I equals to 2, and j equals to 0. So compare these two elements. Here 5 is less than 6. That means ak equals to Li. So in this place we will store 5. This is 5. Then k plus plus and I plus plus. So what is the next value now? Which one will be compared next?
Ma'am, why there is 2 5? One is in position 1 and another is position
Sorry,
5.
sorry, sorry. This is 4.
Yes, ma'am.
This is 4. And that one is now 5. Okay. 2, 4, 5. And here we got 6. And so it's not 5. What will be its value? Nine. Okay. So this is 9. Again, comparison. So what is the value of I now? This portion is done. Look at the, I mean, this, we made some mistakes here. That's why the value are not in the correct position. So we can write the value from here. 4, 12, 6, 9. So our left subarray was 4, 6, 9, 12. Okay, that was the left subarray. And this was our right subarray, that is 2, 5, 7, 11. Okay. So we got how many elements in the correct? We placed only 3 elements in their correct position, that is 2, 4, 5. At first here L and R, when I equals to 0, initially I equals to 0, J equals to 0, and K equals to 0. Okay, so at first we compared Li with Rj, and here this condition is true, right? Li is greater than Rj. So which element will be stored here? Rj. Then whose value will be increased? Obviously J, not
J.
I. That means J plus plus. So here 2 is placed in this position. This is 2. So now the value of J will be increased. J plus plus. So after swapping, it would be great if I can write all the steps here. So that was the next step, where this is 2 and then 6, 9, 12, and in the right subarray the first element is 4, then 5, 7, and 11. Okay, so now k plus plus, the value of k is 1. So now here in this place we will store the next element. And what is the value of j? J equals to 1.
1.
I can write the values here, 0, 1, 2, 3. Actually, we started from, if we consider this as 0, 1, 2, 3, at that time we can say that j equals to 0. But if we use the same index, it's like the original array, then its index value is 4, 5, 6, 7. Okay. So now the next comparison. This position is already sorted. Okay. Now the next comparison will be done between which two elements?
6 and 4.
6 and 4. 6 and 4. Now compare these two elements. Obviously 6 is greater than 4. So Rj will be stored in where? In a kth position. So here, when k equals to 1, 4 will be stored in position 1. So this is 4. Right. So in this array, the next step is 2, 4, the 9, 12, and the right subarray, the data is 6, 5, 7, and 11. Okay, so this portion is now sorted. Now we can compare 9 with 6. You can work on this left subarray first and then right subarray, or you can start with right subarray first. It depends on you. So we can sort the left subarray first. Okay, so these two elements are sorted. Now the next one is 9. 9 will be compared with 6. 9 is greater than 6. Again, sorting. So 6 will be placed where? But in that time, there is some confusion. What was the value of j in this step? J equals to 4. In this step, j equals to 4. So now, when this condition is true, we know that the index of k will be increased as well as j will be increased. So now what is the value of j? J equals to 5. So we should compare 5, not 6. This is 0, 1, 2, 3, 4, 5, 6, 7. Look at this here. We compared 6 with 4. What is the value of I? I equals to 1 and j equals to 4. When this condition is true, now the value of j and k will be increased. What is the value of j now? J equals to 5. So compare 9 with 5. So 9 is greater than 5. Okay, so now here we can store 5. What is the next step? Again, j plus plus. So now this element will be compared with which one? After this process, now here we can store 5 and 9 will be stored in index 5. This is 9. So what is the next step?
I will be increased.
Yes, this portion is sorted now. So now we are going to compare 12 with which elements?
6.
With 6.
6. So 12 is less than or greater than 6?
Greater than 6.
Greater than 6.
Greater than 6. So here 6 will be stored. We can compare this data in so many ways. Okay, we can just compare all the elements from the left subarray, or we can compare the elements, one element from left subarray with one element from the right subarray. Okay, so here 6 will be stored, and then in the right subarray the data is 12. So now the left subarray, or we can say that in this original array, only the first 4 data elements are sorted in their right position. So now how we can sort these array? The elements are 12, 9, 7, 11. Okay, so here look at this. When we are using this way, when we are only sorting these individual subarrays, at that time this process is not actually effective, isn't it? How many times we are comparing these elements? I mean, countless time. So is it an effective way? I don't think so. So can we use another way? Look at this. We can start from here. Just forget about this codes or algorithm. This was our division process, and after the division process we got exactly one element, 4, 12, 6. Now these are sorting algorithms, so you can write an algorithm in several ways. Okay, but you have to find out which one is the most effective. Okay, so then we can use that one. 7, 5, 2, and 11. This was the last step of our division process, right? So we are applying which method here? Divide and conquer. After dividing the array into some sub arrays with one element, now we can start merging them. Now we can merge the data element. Take two neighboring elements. So compare 4 with 12. 4 is less than 12, so it can be stored here. 4, 12, and then 6, 9. We're comparing only two data element. Okay, then 7, 5. 5 is less than 7, so 5 will be stored first. 5 and 7, then 2 and 11. Okay, so after this merging process, now from 8 sub-arrays, we got 4 sub-arrays. Again, merging. So now we'll merge these 2 sub-array and 3rd and 4th sub-array. How? So the first sub-array and the second sub-array is already sorted, right? That means the first element of these 2 sub-arrays are less than the second element of sub-array, right? So now this is, if we want to merge them, after the merging process, we'll get another sub-array with how many elements? 4 elements. Okay, so now how we can compare them? Just compare the first 2 elements. 4 is less than 6, so 4 will be stored first. And then look at this. Here, the next element is 12. And in these 2 sub-array, after the swapping, look at, we didn't swap any element, we didn't change any element. Here, 4, and the next element is 12, 6, and 9, right? So now, which element will be compared now? Can we compare 12 with 6? We can compare 12 with 6, right? And 6 is less than 12, so now 6 will take the position of 12. This is 0, 1, 2, 3. So this is 6, and then 12 and 9. So now these 2 elements will be compared. 9 is less than 12, so it will take the place of 12. 9 will be stored in memory location 2, and then 12. Now look at the second sub-array. How we can merge these 2 sub-array?
2 compare with 5.
First to
5, 7,
compare
2,
5.
11. First 5 will be compared with the first element of the second sub-array, that is with 2. So 5 is less than, greater than 2. 2 will be placed here. This is 4. And then this is 7, 5, 11. What is the next step? Compare the next element 7 with 5, isn't it? So 5 is less than 7, 5 will be stored here. Now the next elements are 7 and 11. 7 is less than 11, so we don't need to change their position. 4, 5, 6, and 7. Okay, now the next step is we have to merge these 2 sub-arrays into one sub-array. Again, comparison. So how we can compare the data elements? In this sub-array, always the leftmost elements are less than the rightmost element, isn't it? So now at first we'll compare 4 with 2. 2 is less than 4, so 2 will be stored here, and 0, 1, 2, 3, 4, 5, 6, 7. So now 4 is here, isn't it? What is the next step? Now compare 6 with 4. Compare. We need to compare 6 with 4, or we can compare the next element. Which one will be effective way? Look at this. If we want, we can compare the corresponding elements from these 2 sub-array, that is 4 with 2, 6 with 5, 9 with 7, 12 with 11. Okay, so here we compared 4 with 2, and then we change the data elements, right? 2 is here, and then 4 is now in location 4. So what will be the next step? Do we need to compare 6 with 4, or we can compare 6 with 5?
6 with 4.
Look at this array. Here 4, 5, 7, 11. 4, 5, 7, 11. This array is already sorted. Okay, so if we want, we can compare 6 with 4, isn't it? So after the comparison now, 4 will be stored here. That is 4. And then now this is the place of 6. This is 4. 4, and this is the place of 6. What is the next step now? In this array, we already changed two position, two data element from index 0 and 1, and the next two data elements are 9, 12, and this in this sub array the first data is 6, then 5, and then 7 and 11. So now next which one will be compared?
9 with 5.
9 and
5.
5. Okay,
6 ma'am.
so
9 and 6.
why 9 and 6? Because 6 is the first element of this subarray, right? So now compare 9 with 6. So 6 will be, but look at this. If we use this way, then again we have to change the location because there is one element 5 which is less than 6,
Yes ma'am.
isn't it?
Yes ma'am.
Hello.
Ma'am, every time when we saw from the left to right.
Try to get the problem first. What is the problem here? We are using two methods. One is division, another is compare or merging. Okay, so when we divided all the elements, we got how many elements in one subarray? One element, right? So now the next step is merging. And how we are merging the element? We're just taking two elements, two adjacent element, and we are comparing them, then we are merging them into one subarray. So from 8 subarrays we got 4 subarray, and these 4 subarrays are in sorted order, so that's why we can't actually change this order. Okay, so here after again merging these two 4 subarrays, we got this 2 subarray, 4, 12, 6, and 9, 5, 7 to 11. Without algorithm, actually, it's not possible to sort the array. So that's why we need to actually find out suitable algorithm. After this merging process, yes, we exactly got 2 subarray. Now, how we can merge them? This was our original array, right? And what is the length of this array?
8.
8. Okay, so this is our left subarray and this is our right subarray, right? And we are trying to sort these original array, because if we merge these two subarrays, then we will get one subarray with one element, 8 element, this one. Okay, so here the first condition is, look at this, if n is less than 2, at that time do we need to compare the data element? The first condition is if n less than 2, do we need to make any comparison? No, isn't it? This is our array with 8 elements, but suppose it can happen that the given array has only one element, so at that time we need to divide them. No, we don't need any comparison. Okay, but here n is greater than 1. Here n equals to 8. So at first we divided the array into two subarray, isn't it? How we divided the array? N by 2 equals to 4, and we took the elements from lower bound to mid minus 1, that is from 2 to 6 in the first subarray, and then the elements from mid to upper bound in another subarray. Right? So suppose now this is our left subarray and this is the right subarray. And if we use some loop variable here, suppose here I is a loop variable for the left subarray and j is another loop variable for the right subarray. And here in the original array we can use another loop variable k, and its initial value is 0. Okay, so how we can now compare the data elements from left subarray and the right subarray? There are two conditions. Okay, if we want, we can use previous method where we compared one element from the left subarray with one element from the right subarray. Or you can do one thing. Suppose here in the left subarray, when I equals to 0, li equals to 4. Isn't it? What is the value of li? 4. Okay, and here in the second subarray, when j equals to 0, rj equals to
5.
5, right? And after comparing these two elements, we got that this element is less than the this element 5. Okay, that's why we placed 4 here. Initially 4 was there. Look at this two subarray. 4 is less than 5, so now we can follow that step, that is ai equals to ak equals to li. So here k equals to 0, ak equals to now li, that is 4. Okay, then what is the next step? Now I plus plus. What is the value of I now? I equals to
1.
this is 0, this is 1. So compare this element with the first element of R. Compare L1 with R0, Rj equals to 0. So 12 is greater than 5. So
5.
now here we'll store 5. That is 5. Okay. So now we took one element from the right subarray and stored it in the original array. That's why the value of our j will be increased on j plus plus. Here j equals to 4, then 5, 6, 7. So now what is the value of j? J equals to
5.
7. Why? Okay, so change the value. This is 4 and this is then 4 and 5, so 4 will be stored here and this here j equals to 4. What is the next step? The next step is j plus plus, that is j equals to 5. Hello.
Yes, ma'am.
Hello.
Yes, ma'am.
Yes, ma'am.
Which data element will be compared next? Okay, let me define the steps again. The first condition was li less than rj. So is it true here? Is it true or false? Li less than rj.
Yes, ma'am.
True, ma'am.
The condition is true. Look at this. There are two conditions. There are 3 array. One is the original array, one is left subarray, another is right subarray. We are using 3 variable. One is k for the original array, one variable I for the left subarray, one variable j for the right subarray. Okay. Now there are two conditions. The first condition is if li less than rj, then lith element will be stored in akth position. Okay, so here which condition is true? The first condition, that is li less than rj, then the value of I will be increased, not j. Here we made the mistake actually, not j equals to 5. That was our mistake. Okay, so look at this. When the first condition is true, then the value of I will be increased. So now I equals to 1. Now 12 will be compared with 5. And after this comparison, now the second condition is true. What is the second condition? The second condition is li greater than rj. If that condition is true, now the after swapping, the value of j will be increased. So here the second condition is true. li I equals to 1, 12 is greater than 5. So now ak equals to rj. What is the value of k now? K equals to 1. So here we'll store rj. And what is the value of j? J equals to 4. So 5 will be stored here. Now this is correct. What is the next step? Now I plus plus or j plus plus? This is now
J plus plus.
j plus plus. This is 5 and this is which two elements were interchanged? 12 and 5. So this is 12. So now j plus plus. What is the value of j now? 4 or 5?
5.
5. So if j equals to 5, then we'll compare which element? Obviously this one.
6.
6. Okay. So again, that means we are increasing the value of I. Why? Look at this. When the second condition is true, the rule was increase the value of j plus plus. But here we are also increasing the value of I, isn't it? So why actually this problem is arising? Did you find it out why we are facing the same problem again and again? Because we are changing the value in this left subarray. That's why. When we are storing some elements from the left subarray and the right subarray, we are actually storing it in the original array, right? Where we are making the changes in the original subarray, isn't it? So we don't need to actually change the value here. So now look at the subarray was 4, 6, 9, 12, and that's 2, 5, 7, 11. Okay. So what is the value of I now? The value of I will not be changed. Here I equals to 6. And the value of j will be increased. What is the value of j now? J equals to 4, that is 5. So compare 6 with 5. Hello. I don't know actually what is happening today. Why I'm making this thing so complex. So let me just share the idea with you again. Then you can solve it by yourself. Okay. Or if you couldn't solve it, then please tell me in the next class. I'll try to solve it in the next class. Okay. The main concept is in merge sort algorithm, we'll use divide and conquer method. Okay, so at first divide all the elements into some subarray with one element. Now, how we can merge the subarray? There are some rules. The first rule is we have to find out whether the array length is greater than 1 or not. Yes, here the array length is 1, otherwise we couldn't divide the array. Okay, so in merge sort, you can apply two conditions. The first one is whether li is less than rj, and other is li greater than rj. So when li is less than rj, then take the value from left subarray and then place it in the original subarray, because here the element of the left subarray is smaller than the element of the right subarray, and we are using merge sort for arranging the data in ascending order. So after that, the value of I will be increased as well as k will be increased, and please don't change the value here in the left and right subtree. Now the second condition is li greater than rj. That means now in the right subarray there are some elements which is less than the element of the left subtree. That means we'll obviously take the smallest element. So now the right subtree has the smallest element, so we should collect the data from the right subtree and then we can place it in the original array. After that, after taking a data from the right subtree, now the value of j will be increased, that is j plus plus as well as k plus plus. So you can apply these two rules until you got all the items in their right position. Is it clear? Just tell me, is this algorithm clear to you?
Yes, ma'am.
Yes,
Clear,
ma'am.
ma'am.
So if the
Yes, ma'am.
algorithm is clear, then you can easily sort the array. I don't know what is happening to me today. Okay.
Okay, ma'am. Ma'am, but
So
I have a problem, ma'am.
yes, yes, yes.
Our previous lecture slide, can you give us, ma'am?
What was our previous lecture?
Yes, ma'am. Previous lecture slide. This will be very helpful for our assignment, ma'am.
Tree. Are you talking about tree?
Yes, ma'am. Tree.
Okay. So did you all download the book? That is data structure.
Yes, ma'am.
Name of the book is Data Structure with C, and the author name is Same or Lipsels, and it's a book of Shom's series, Shom's outline. Did you collect that book? And I'm actually um, okay, so please download that book, and I can do one thing. I can upload that book, but the problem is the soft copy that I have is incomplete. I mean, some pages are missing. That's why I didn't upload that book. So you can do one thing, please download that book and all the
Ma'am, please,
materials are there.
yes, ma'am. Ma'am, please mention the book name also, ma'am.
Okay, I'm writing it here.
Madam, I tried to download that book, but same thing. Most of the pages are not
Yeah.
visible. At the last page, after the tree.
Yeah, that's the problem, yes. And I tried to download it from several sources, but I got the same book. That maximum pages are lost. That's why actually I didn't upload that book. But actually I have the soft copy, so okay, I'll do one thing. I'll try to create a lecture note for you, and then I'll upload it. Okay, but I need some time. Maybe on Sunday I can upload it. The name of the book is Data Structure with C. And the other is and the book of Sean's outlines. The publisher search. Okay. This is our reference or textbook actually. So maximum topics are actually taken from this one, this book. And the next class I'll try to discuss the smart sort again, but I hope you can solve it by yourself. Okay, so, and I already told you the algorithms. So please try to solve it. And we need to discuss two more sorting algorithms, that is quick sort and radix sort. After that again we'll start graph. From graph I'll discuss only one or two topics. That is the some shortest path algorithm and minimum spanning tree. I'll discuss only two topics from graph, and that will be the last topic. Okay, so the syllabus that I have to actually cover. These are, I have to discuss three more sorting algorithms. That is merge, quick, and radix sort. And two topics from graph. One is minimum spanning tree. And the last one will be shortest path. And if we have some time, then I'll try to discuss another topic, which is Tower of Hanoi. If we get some time, then Tower of Hanoi. So only these four topics are left. So now please respond.
Madam,
Yes.
Madam, where are we gonna submit our assignment?